Big O is a measure of how well algorithm scales as the amount of input increases. Want a simpler definition? It measures performance as code handles more data. How? With time complexity notations like this. Want a picture? Check out BigOCheatSheet.com. But let's check out some common notation, starting off with logarithmic, also known as O of log n. An example would be like this binary search function, which takes an array of numbers from line 7, uses logic in a while loop, and on line 21 returns the index of the number being searched. This is fast, as you can see here on our chart. Another example is linear, also known as O of n. Linear code implies running time increases at most linearly with the size of the input. So in our example, if each element in the array on line 5 takes 4 milliseconds to process, then the function below will take 12 milliseconds to process since it's 3 elements long. This is still kind of fast, as you can see on our chart here. Let's see one more. Quadratic, also known as O of n squared. An example is bubble sort function, which sorts our numbers arrays from line 5 in ascending order. This function will take n elements and compare each element to every other element. This is slow, as you can see here on our chart, and not recommended. When you write code, you want to know how best to describe its performance relative to data input, and Big O lets you do this.